Alright, it's time for the PCB Spot Welder Showdown Part 1. I have, I think, another 3 other spot welders in the mail waiting to arrive, and I'll do a Part 2, but here's Part 1. And these are the most common spot welders that you find on eBay and AliExpress and that, and so I started with these. I have searched for some more hard to find, weirder spot welders, and I'll do a Part 2 and look at those, but here's what we're starting with. The most common one that you find is this version with the 5 Mosfets. This is the most common one when you search PCB spot welders, and this is similar to my old spot welder, but this is a slightly different version because the button works differently, but physically it looks the same as my old design. This is another design that I found. Has 4 Mosfets, you know, we'll test it in a second and see how it goes. But this one, you know, this is a smaller, more compact one with 4 Mosfets. There's this version here with the 8 Mosfets and the XT60 directly on the board. This one, you actually are required to solder the leads directly onto the PCB. There is no actual lugs, where every other board you screw on the leads. These ones you solder on. So there's this version, and then there's these versions where they come with a like pouch cell to power the, you know, they come with their own pouch cell to power the spot welder. If you can look, I've already blown this one up. This pouch cell was, let's get this one out of the way since it's already blown up. This one was quite a disappointment. This battery claims to be 65C and 8000 milliamps, which means it should be able to push over 400 amps. But one problem is, A, it's only 3 volts. This, you know, it's only 3 volts. But secondly, this PCB, you know, it only has the 3 Mosfets, and this thing was incredibly weak. The reason I blew up the Mosfet is eventually I just said screw it, and I hooked up my big LiPo battery to it, and I knew that, you know, I knew that this was 3 volts, I knew this was 12 volts, but I just hoped you know, I didn't know if the electronics were 12 volt compatible, but I just went for it. And actually it did fire up and turn on, but the second I did the first spot weld, that blew the Mosfet right out. And again, you know, it's because they're using just 3 Mosfets for, you know, over 400 amps, and 3 Mosfets just can't handle over 400 amps. So this did blow up. There's another thing I don't like about this board is, you know, these are your battery terminals. These are big exposed battery terminals, and you know, you guys have seen me. My workbench gets messy when I'm working, and I'll have a piece of nickel laying on the counter, and I'll put this battery down. Well, if you touch these 2 terminals on a piece of nickel, you are gonna blow something up. These are just big exposed terminals that I'm not really comfortable working with. You know, at least this battery, you know, the terminals are hidden, and then, you know, on your PCB you can put a bit of Kapton tape around the PCB, but I'm not happy or comfortable with having these huge terminals sticking out like this on a big pouch LiPo. But anyways, so this style with the integrated LiPo was a bust. I think it was about 25 bucks, but this was easily the worst spot welding machine I've ever used. I mean, I doubt it could weld 0.1, let alone 0.12 or 0.15. So this thing was garbage, and I'm not sad that it blew up. It was a piece of junk. So that takes us to these 3 here. We are going to do some testing right now. I am going to use the thickest stuff you can get, which is the 0.15. The 0.15 is the really good stuff. And the reason I'm going to use the really good stuff is that should separate the, you know, the men from the boys. if the spot welder can handle the 0.15 and particularly if it can spot weld 0.15 onto itself, now we are talking. Now we're starting to get to the levels of a true plug-in machine. You know, 0.15 is sort of the thickest nickel you can you know, normally get. So if we can spot weld the 0.15, we are in business. So that is what we are going to test first. All right, I will set this up and bring you back. Okay, for this initial testing, you know, I am going to be using my own needles and my own 10 gauge silicone wire. These spot welders all seem to come with 12 gauge silicone wire and these little tiny needles. And I just don't think it can handle what, you know, a 400 amp LiPo can deliver. So I'm not going to use these. I will do a quick test at the end just to see how these compare to the bigger needles and the bigger tips. But for now, all the testing to make it, you know, to make it apples to apples, all the testing will use this LiPo and these needles, and we'll see how it goes. So this is the first spot welder. This is the one that was the same design as my original spot welder, but the software is a little bit different. So this one, you have to you kind of have to hold the button until eventually it goes into red mode. And it's really annoying. This software does not work very well. Okay, finally we are in red mode. And again, we're using the thicker 0.15. Let's see how this does. Now red mode should be maximum current. So let's just see what happens. Okay, 1, 2, 3, and 4. Okay. Not too bad, not too good. Let's see how. Oh, it's actually kind of on there. It's kind of on there. That's not bad, actually. That's not too bad. So that's good. Now we will test it in a second with double nickel, see if it can handle double nickel. You should know, for whatever reason, spot welders always weld better on the negative side of 18650s and always have a tougher time on the positive side of 18650s. I don't know if there's a metal difference or the smaller shape. I don't know what it is, but I always have better luck spot welding the back than I do on the front of an 18650. Okay, that is spot welded. You know, now let's see how it does with some double nickel. Okay, so okay. Not too bad. It put up a little bit of resistance, but it didn't tear the nickel when I took it off. The spot welds definitely gave away. It did not tear the nickel. So let's try that one more time. Yeah, it's just okay. It's just okay. I'm relatively happy with how it's spot welded. How it's spot welded on the actual cells itself, but it doesn't quite have the current to do double nickel. Yeah, that almost tore the nickel a little bit, so that's pretty good. This is doing a reasonable job on the thickest nickel you can get. So this is not a bad spot welder. Let's move on to the second spot welder. Okay, spot welder number 2. Now this spot welder is smaller physically, has 4 Mosfets compared to the last board, but it does have one interesting feature. it kind of has these, might be hard to see. Maybe I should, let me undo this so you can see. It has these like raised traces to help deliver current. So it has these big beefy sort of raised traces that stick up off the board to help deliver the current. So, you know, even though it is physically smaller and has fewer MOSFETs, it does have some of the beefier traces. So, you know, hopefully that goes in its favor. Anyways, let's turn this spot welder on and see how it does with the 0.15. See how this one works. Like I said, everyone works differently. Okay, this is one with colors. Okay, so this has 3 levels. Green is the weakest, blue is the middle, red is the toughest. So that's good. So we're on red. We're on the most current, and using the exact same needles and battery cable as before. Let's see how this one does. Okay, 1, 2. Okay, there we go. We are done. I had a few little blowouts there, so those are bad to judge by. But if we find 2 batteries that are, this is this current one I'm doing, this is the other one. The current one might actually leave a slightly stronger spot weld. If you compare, it does seem slightly deeper than the first one. Even though it has fewer MOSFETs, it does seem to be delivering a slightly deeper weld. So let's see how it does with the double nickel, since that was a challenge for the other spot welder. Okay, we got some double nickel on there. Let's see how it did. Did okay. I would say that these 2 spot welders are comparable. This one has more MOSFETs, but this does have that interesting beefy trace on it, which may be helping it. It's hard to tell. Let me try and rip some of this off. Yeah, that was pretty good. And in fact, it did tear the nickel. So I am gonna say that this PCB outperformed this PCB. And again, I do think the number of MOSFETs is sort of indicative of how good of a PCB spot welder it is. But in this case, it has fewer MOSFETs, but it has beefier traces with those big beefy standoffs for the cabling. So this PCB, I think has a slight edge over this PCB. All right, let's try the third one. Okay, the third spot welder is this one. It has 8 MOSFETs, and this is the one where you actually have to solder the spot needles onto it, and it has the XT60 directly built into the board. I have already played around with this one in a previous video, and it is excellent. Excellent. It is a very strong spot welder. We'll compare it to these ones in a second, but I will tell you that this one's gonna win by a mile. This one actually has, I think, 8 power levels. It has all these colors: red, green, blue, white, yellow, purple, blue. So I think it has 8 power levels. Just using it on like halfway, which is white, this thing has been very impressive. So let's lay down a few spot welds with this one at 50% power. Okay, there we go. I want you to compare the depth of the spot weld between these three. It's PCB1, PCB2, PCB3. You can see it's night and day difference as to how intense the spot welds are on this PCB. And the other thing about it is it's very consistent. It hits consistently hard. These other ones, I kind of get like it's like 70% good spot welds, 30% weak spot welds. It's a little bit mixed because we're kind of pushing the other ones to their limits. This one just consistently hits hard without even strike. We're only running at 50% and it has no problems making these. Now let's try double nickel. Again, this is 0.15 double nickel, and we'll see how it sticks. Okay, let's try peel that off. Can you see? It did tear the nickel. There is a bit of nickel torn off there. It did come off relatively easily. I'm going to do that one again, but this thing has absolutely no problem spot welding the double nickel. You can see, yeah, it just ripped a hole clean through the nickel. So this thing is definitely my favorite spot welder. There is one issue with it. Both of these needles are already almost hot to the touch. I've only done 10 spot welds, and these are almost hot to the touch. This PCB can only go a couple minutes at a time without taking a break. The PCB gets hot, but even worse, these needles get incredibly hot. I truly believe that these 8 Mosfets are delivering all 400 amps that this battery can drop, and it's coming out in the tips of these needles, and these needles get very hot. But it does deliver a hell of a weld. You can see removing the nickel off the battery totally tore the nickel off the battery. So yeah, the only way the nickel's coming off with this spot welder is by tearing the nickel, which is what we want. To wrap up between these three, these two I think are very let me unplug this before I short something out. This is the original design of my original spot welder. It's not bad. I do think this one might be slightly stronger. Just probably, even though it has fewer Mosfets, I do think the way they did the traces is a little better. And but none of these even hold a candle to this spot welder. This thing is amazing. It really delivers probably 2-3 times the current that these are capable of delivering, and it shows in the spot welds. I am very glad I found this. The only downside is that you can't spot weld much with it before it gets hot. So I may use one of these to lay down my initial nickel, and then use this for the bridging double nickels or something like that, some combination between spot welders, just because I can't realistically have to take a break every 2 minutes when I'm building a battery. I need to work continuously for an hour or two to get a battery done, and I can't be stopping every 2 minutes. So that is a problem with these. This is very impressive. Now, there is one other test I'm going to do quickly. I don't, you know, it's possible that this is working so well because the leads are soldered, whereas everything else is bolted down and running through these little copper eyelets. We don't know how much current is being held back and how much resistance is created through the bolted connection. So I'm going to take this PCB and I'm going to solder on leads to it. Just because this was the worst performing, and I want to see how it performs soldered with soldered connections and see how much of a limiting factor is the bolted connection. So that's all we'll do as a final wrap up, is do one more round with this with soldered connections. Okay, I have soldered leads on and power connections onto this board. Let's see if it does any better. Now I am actually going to try out the stock needles. This is 10 gauge wire here, but I am going to try these stock needles. I am interested to see how the stock needles do. So this isn't technically an apples to apples test, but I kind of want to see what this board can do with sort of the stock needles, with some 10 gauge wire and, you know, soldered connections. Let's see if it can do any better than what it did. So let's turn this board on. This is the one that's a real pain to turn on to get it to go into red mode. Okay, we're in red mode. So let's lay down some nickel here and let's see how this does and see maybe it blows up. Let's find out. This is what this board did originally. This is what the board did now. I would say comparable. I would say there isn't much of a change. Let's see how it does on double nickel. All right, let's get another piece of nickel and let's see what it can do. Did not rip the nickel. I would say completely comparable. I would say that the bolted connection is completely comparable to a soldered connection. So this one isn't so good because it's soldered. This one is so good because it has 8 Mosfets and these gold nice tracks on it. So anyways, I think that's the end of this video, and I will do a part 2 when I have, like I said, I have some really weird and different spot welds, PCB spot welders coming in with some different designs, and all of the other ones that are coming in I think have at least 6 Mosfets to try and really get beefier spot welders, and we'll see how those do, and I'll do a part 2. Thanks for watching, and please subscribe if you haven't.